All right, 8.5. Use properties of trapezoids and kites. Trapezoids and kites. Kites are figures you probably didn't use much in middle school, but we do talk about them in geometry. Yeah, I've got a little string here. All right, let's dive into trapezoids. All right, trapezoids. Let's make sure that we have some of the same terminology when dealing with trapezoids. Remember, trapezoid is one pair of parallel lines. We call these the bases. And we call the other segments legs. Just wanted to make sure we wrote that down. Suppose it's not legs, plural, just leg. We have our bases. Now that we have that, let's dive into a problem to see if it's a trapezoid. Trapezoid is one pair of parallel lines. Well, obviously these are the only ones look parallel because this is a negative slope and this is a positive slope. So to find that, we're going to have to find the slopes here. Notice this has a rise of 2 and a run of 6. If I were to dot that out, that means that this slope is 2 over 6, which is equal to 1 over 3. This line has a rise of 5 and a run of 15. Well, 5 over 15 is equal to 1/3. Since the slope of base 1 is equal to the slope of base 2, these two bases are parallel, which means, yes, this is a trapezoid. All right, the next concept has to do with isosceles trapezoids, one of the tools I got here. Isosceles, first of all, if it's a trapezoid, one pair of parallel lines. The other case, to make it isosceles, means these two segments are congruent. Awesome. Let's go ahead and prove or work out a concept dealing with isosceles trapezoids. Now, an isosceles trapezoid can be thought of as part of an isosceles triangle, given that this segment and this segment are congruent. That being said, we can just chop off this triangle and then we would have an isosceles trapezoid. Now, if you remember from the isosceles triangle, the base angles are congruent. Now, if the base angles are congruent and the sum of the angles is 360 and these two lines are parallel, then this angle must be congruent to this angle, which is the first theorem we have to work with. And the second one is quickly proven from that. But the third theorem that I've got on page 543 requires just a little bit more thought. All right, next theorem still deals with isosceles trapezoids, and it's also about its diagonals. Now, the diagonals in an isosceles trapezoid are congruent. And let's do just a quick map out of a proof. Remember, if it's a trapezoid, two lines are parallel. Also, these two segments are congruent if it's isosceles. Now, remember that the base angles are congruent of an isosceles trapezoid. Now, if this angle is congruent to this one and this segment is to this one, then we've proven that two sides and two angles are congruent between two triangles. Let's go ahead and mark out those triangles with some points. A, B, C, D. Note that triangle ABD has angle A, and it has segment AB congruent to angle D and segment DC in triangle DCA. We need at least one more side or another angle in order to prove the two triangles are congruent. Note that segment AD is shared between the two triangles. That gives us side angle side. And since those two triangles are congruent, then all of their corresponding parts of congruent triangles are congruent. And that's segment BD and AC, which are the diagonals of the isosceles trapezoid. That means that the diagonals of isosceles trapezoids are congruent, and we can use that in solving problems. Next concept has to do with the mid-segment of a trapezoid. Mid-segment. And the name itself indicates what we're talking about here. To be a mid-segment, it connects midpoints. That means this point is the midpoint of this leg. Likewise, this one over here, these two segments are congruent because that's the midpoint. All right, quick theorem about this. Remember that this is a trapezoid, which means these two lines are parallel. And if these two segments are congruent and these two segments are congruent, and a few more things which I'm going to let you think about and we'll talk about more in class, is that this line is parallel to the other two lines and it's half of the sum. You can think of it as the average between the two segments. I'm going to use variables to talk about it. The textbook uses A, B, C, and D. So I'm going to say that x plus y divided by 2 is equal to segment Z, the mid-segment. The next concept has to do with a kite. A kite is a quadrilateral with two pairs of consecutive congruent segments. 2 pairs of consecutive congruent segments. We call this a kite. All right, that's a kite. Some theorems about a kite. All right, one theorem. The first one, the diagonals are perpendicular to each other if this is a kite. So this segment's equal to this one, and this one is to this one. So this is perpendicular to this segment over here. Now note that these two triangles share this segment. And they share this segment. And this larger triangle is congruent to this larger triangle by side, side, and they share this side right here. That means that the corresponding angle here is congruent to this angle. Then we can use side angle side to say that these two triangles are congruent. Well, if that's true and these two angles are congruent because corresponding parts of congruent triangles are congruent, then this must be 90. The next theorem about kites is a little easier to prove, at least work it out. Now to do so, we're going to have to draw an auxiliary line, that being this diagonal right here. We take that diagonal and we go ahead and mark up some things we do know about the kite, and that the 2 pairs of adjacent congruent segments, oops, it's supposed to be a 1. We're going to prove that this angle over here, we'll call it angle A, is congruent to angle B. Let's call this up here C, and let's call this D. Notice, if this segment is congruent to this one, and this is to that, and this is congruent to itself, then these two triangles are congruent. If that is the case, these two angles must be congruent by corresponding parts of congruent triangles are congruent.
One has to do sauceless trapezoid. Let's dive into some problems.